As you can see over here, I copied over the pinball game from Windows XP to my Windows 10 machine, and today we're going to screw it up a little bit. So I'm going to show you that it's working perfectly fine currently. Let's go ahead and just start a little game here. Now let's go ahead and screw up a little bit the graphics of the game. And for this I'm going to use WinDBG, so if you don't have it, you can get it on Windows Store or using the WinGet package manager. And what I'm going to do here is connect as a debugger to Pinball. So I'm going to press here on File, and then Attach to Process. And I'm going to click here on pinball.exe. First command I'm going to use is lm, that's going to be list modules. That way I'm going to see all the DLLs that are currently loaded. These are the modules that are currently loaded. We can see stuff like, let's say, kernel 32 or shell 32, like popular stuff. This is basically DLLs that represent a lot of the Windows API, also user 32. But a cool thing is that if I just scroll a little bit upwards, we can see Pinball as well. Even though Pinball is not a DLL, but it's actually the executable itself, it's still listed over here as a module. Also, we can see that we have PDB symbols. That means we have debugging symbols, and that is really cool. This is actually grabbed by the Microsoft official symbol server, so apparently Microsoft still holds symbols for Pinball. Anyway, we can just examine the symbols by running the X command. And then I can just say Pinball, exclamation point, and I can put a wildcard here, and this will just list all the symbols. So this will include functions and variables that are defined in Pinball. Let's take a look. So you can see that they wrote Pinball probably in C++, because this is definitely C++ naming style. Also, we have it over here. But we have here a lot of symbols. I want to narrow it down a little bit. I want to do something that is related with graphics. So let's narrow it down to everything that starts with render. So I'm going to add here render before the wildcard. Now let's go ahead and press enter. And now you can see a lot of render related stuff like render remove ball, render paint. Let's go ahead and take a look at render paint. So for this I'm going to use the BP command. That's going to be breakpoint. I'm going to place it on pinball render paint. Now I'm going to run G to continue. That's going to be go. Now we can see that the debuggy is running. Even just going back to pinball, it's going to already stop on render paint because it's rendering something on the screen. And we can see that the first assembly instruction that it's running is calling render paintballs. So I'm going to step inside of this instruction by running F11. And now you can see we're inside the render paintballs function. So I'm just going to continue stepping with F10. That's going to be step over. Now we arrived at the function that is called gdrv copy bitmap. This looks interesting because I want to go ahead and screw up the graphics a little bit. Let's see if I can screw up copy bitmap and make it copy something else. So I'm going to step inside. That's going to be F11. And now you can see I'm inside of copy bitmap. So I'm going to continue stepping with F10. Notice what is going on right now. It seems like I'm inside of a loop. Notice the counter here. We're currently on C4. Let's see if we're going to be back at C4 shortly. So I'm going to continue pressing F10. And again, we're back at 8 C4. Let's give it one more time. And again, we're back at 8 C4. So this is probably the loop that is copying the bitmap information. That's going to be the red, green, and blue colors. So let's just make it copy black instead. Black is all zeros. So for this, I'm going to go again to the beginning. And it looks like it's starting from C2 because you can see before C2 we're on CB. So from CB it's back to C2 and then C4. So in this case I'm going to go ahead and list the assembly instructions that are starting from this address. So I'm going to copy this by right clicking on this after marking it. And I'm going to use the U command. That's going to be unassemble. So this will disassemble from this location in memory. And now I can see the assembly instructions that are copying the bitmap information. This looks like a classic memory copy. We can see here an incrementation of EAX and ECX, these are probably the pointers, and copying a single byte from EAX to BL. This is, by the way, dereferencing the pointer value that is EAX. So it's just running on EAX and ECX and copying the information into BL, and then BL into ECX. So I think if I want to make everything black, I want to cause it to copy zeros into this. So I'm going to go ahead and replace the assembly on this line, which is currently copying information from EAX. I'm going to replace it by just zeroing BL. So how can I do that? Well, I'm going to first of all copy the address over here. That's the address in memory. And I'm going to use the A command. That's going to be assemble. Now I'm going to paste the address. And now I can write a new instruction which will come in place of this. So what I'm going to do to zero BL is I'm going to run XOR BL with itself. If you XOR a register with itself, it's going to make the register 0. because XOR is a logical operation which will just make everything 0 if you do it on the same number. And now I can see everything is fine because after this I'm on C4, so we can see that this instruction took 2 bytes in memory. And C4 is fine because this is exactly the size of the original instruction. So everything is going to work fine. We didn't screw up anything else. So to end this, I'm going to just press enter with nothing. And now I'm going to clear the breakpoint with BC. That's going to clear all the breakpoints, and I'm going to press G to continue the execution. Now we're back here in Pinball, and let's see what happens right now. So I'm going to press here space to start the game. Notice what is going on. The ball is leaving a trail. That is really cool.